Alright, looks like we are live. Okay, let's continue. Let me open the table of content first. We are on chapter 5 on homework code section here. Okay, let me open this. Okay, we are in this homework code. We are to take a look about accessing variable from parent and child process. We also try open file from parent and child process, but currently I'm still not sure how to write to the file at the same time from parent and child process, I assume. So I haven't, what is it called? I'm not sure how to answer this question yet. So we move forward to the third question here. It is ensured that child process always print first without calling wait or wait PID system call in the parent process. So far we have found 3 solutions, I guess, for that. The first solution is using select and signal here. Again, I'm not really sure if this is the correct way to use select, but yeah, we use select because of the timeout to block the, what is it called? To block the parent process according to the timeout here. It is 10 seconds, right? And this is microsecond, the second one. So we block the parent process for 10 seconds, and then when we get the signal child, which means that the child process already terminated, we execute the signal handler here, which will print goodbye. Here, parent process would print goodbye, right? So that is the first solution. And then if we take a look at the signal main page here, there is a warning, right? The behavior of signal varies across unique version and also vary historically across different versions of Linux. Avoid its use, and the suggestion is to use sig action instead. So that's what we do, or I do, I guess. Instead of using signal system call, I'm trying to use sig action. This is the second solution, but the concept is kind of the same. When we got the child signal, we execute the signal handler here, which will print the goodbye message and also sleep for 5 seconds, because I'm trying to check about the signal max. Here it is, which means that we get, what is it called? When we trigger the sig in, like use signal interrupt like using Control C during the 5 seconds, we will not immediately we will ignore the signal and not interrupt the process. I can demote that like this using Control C, right? We are not interrupting the process, but after that we will deliver the signal interrupt to the main process or main function in this case. See, there is a difference in the exit code. So there is the second solution. The third solution is using the, what is it called? The sig wait here. So instead of what is it called? Instead of checking the signal asynchronously, we check the signal synchronously, So we use wait to wait for the signal or one of the signal in the signal set to be pending, and then we execute this one, the code later on, the next code. Okay. So yeah, if we didn't make the signal pending, the SigWait will what is it called? Will hang the process, I guess. So that's why we need this one for the single thread application. Okay, I think I can show that. Okay, and now if we comment this, see, it will keep waiting until the signal in this one of the signal in the signal set ready. In this case, sorry, not ready, pending. In this case, it is the sig type. So there is that. That is the second, the third solution. And now we are trying the fourth solution. Wait a minute. And before that, I want to check this is a handler, I guess. Not that one. Yeah, I want to check, is it gonna be null when declare like this, declare the stack like this, Self file trick. Okay, it is nil. Interesting. Alright. Okay, let's continue reading this. Okay, I did read this. signal handler interfer the actual block to the safe context of the main program. Okay. Create a pipe that the process can use to read to itself. A pipe consists of a file descriptor, one for reading and one for writing. Register minimal handler. The actual signal handler does only one thing. It writes the signal number to the right end of the pipe. Since write is an async signal save function, this is a save operation. The main program uses an input-output multiplexing function like pull, select, or pull to monitor the rear end of the pipe. Okay. When a signal occurs and the handler writes to the pipe, pull notifies the program that the file descriptor is ready to be read. The main loop reads the signal number from the pipe and calls the appropriate predefined callback function to handle the signal. This entire process happens within the safe context of the main program, not the signal handler context. Okay. Effectively, this transforms an asynchronous signal into a synchronous file descriptor input-output event, allowing you to handle it consistently alongside other events like network socket. Okay. Signal set action descriptor. Okay. Okay. I assume this is when we write to the end of the pipe, I guess. See, one for writing. I mean, yeah, one of my concern is that if we take a look at check action main page here, where is it? This one. Possibly with unspecified whether a child signal is generated when a child process terminates. So on other operating systems other than Linux, child signal might not be generated when the child process terminates. So maybe we can use maybe we can use a pipe trick here to make sure that the child signal always generated. You know, maybe let's find out. Okay, we need also to close this set action. Okay. Error. Okay. Oh, using set action. Okay. So even when using save pipe trick, we Still need to use seek action to register the action. Okay. Now see. Running call, okay. System. Something done gracefully, okay. Oh, signal set action, okay. Ignore sec pipe. Okay. Oh, wait a minute. So we are using seek action here for what is it called? To handle the seek in and seek term, and also ignore the seek pipe. Okay. Pull FT. Waiting for a signal or other event. I mean, can we like just put this in the signal max, you know? Yeah, I'm not really sure. Okay, let me read this first. Okay, we're using pull in this one. Signal event detected. Okay, polling. Can I check the struct? Nothing. Okay. Maybe in the pool main page here. Okay. File descriptor, request event. So, okay, event, return event. Signal init. WebFT. Wait a minute. Signal get FT. So we are putting the negative one file descriptor in here. Is that it? If this field is negative, then the corresponding even field is ignored, and the add even field returns 0. This provides an easy way of ignoring a file descriptor for a single pull call. It's bitwise complement. Interesting. So we set this to -1. Okay. What is this NFTS parameter here? Oh, there's also timeout. NFTS. Let's see. The number of items in the FD array in NFTS. Limit no file. Yeah, I mean, wait, the NFTS is 1. Oh, is it? What is it called? The total number of file descriptor, is that it? Num open FTS, number of open file descriptor. I assume then what about the timeout? The number of millisecond, okay. Millisecond that pull should block waiting for file descriptor to become ready. Will block until either a file descriptor become ready, the call interrupt by a signal handler, or times out expire. Being ready means that the request operation will not block those pulling regular file, block device and other file with no reasonable pulling semantic always returns instantly as ready to read and write. System clock binary and kernel scheduling delays mean that the blocking interval may overrun by a small amount. Specifying a negative value in timeout means an infinite timeout. Okay. So that is the meaning of -1 here. Infinite timeout. Specifying a timeout of 0 cause pull to return immediately, even if no file descriptor are ready. Okay. There is data to read. Okay. There is some exceptional condition on the file descriptor. possibilities include out of band data on a TCP socket, pseudo terminal master in packet mode. Okay. Pull out. Writing is now possible. To write larger than the available space in a socket or pipe will still block. Okay. And condition only only return in an event, ignore in event, not that when reading. Wait a minute, let me check the action. Okay, well. Let me check this example. This is example using pipe. Let me copy this in the chat in case anyone wants to take a look. Wait, let me check. Is people? Oh, looks like people is not in the POSIX standard. Okay. Return value. It is the number of elements in the pool FT have been set to a non-zero value. That the system calls timeout before any file descriptor become ready. Never not an error in the pool FT. An event field have been set to a non-zero value. What is it again? Pool FT. Okay. Oh. Return value. Okay, there's an example in here. Open each of the file name in each command line argument and monitor the resulting file descriptor for readiness to read. The program loops repeatedly using pull to monitor for the file descriptor, printing the number of ready file descriptor unwritten. For each ready file descriptor, the program displays the written event field in a human-readable form. If the file descriptor is ready, add some data from it and display the data on standard output. And if the file descriptor was not readable, but some other event occurred, close the file descriptor. And close the first in first out output. For return 3 times. Okay. Using Carlock. Interesting. Open. Maybe we should try this example first to kind of understand how the pipe system call works. Hello, Anurag. Welcome. Are you learning about process in operating system? Yes, I'm learning about process in the operating system. Okay, welcome Ajik. Right. Yeah, I'm on the section, what is it called? I'm reading this book called Operating System 3 Easy Piece. I'm currently on chapter 5 about the process API and currently trying out the homework code section here to make me understand more about the process API in the operating system, such as fork and maybe with system call too. But yeah, this is the question that I'm trying to answer. Ensure that that process always print first without calling with or with PIT system call. So some of the solution that I found is using the signal, like the sig action or the signal system call. And when we found the signal, we execute we execute the signal handler here, which will print the message goodbye to to fulfill this condition, the chat process print hello and the parent process print goodbye. is one of the solution, and now I'm trying out the self-trick pipe in here. Self-pipe trick. So I'm kind of trying to understand about the pipe system call with this example. Yeah. Oh, we also use read. Read. Oh, okay. There's 1P and 3P section. What is that? POSIX Programmer's Manual. What about 3? Okay, I'm not really sure what is the difference yet. Let me check this. To read up to count bytes from file descriptor FD into the buffer starting at buff. Okay. On files that support seeking, the read operation commences at the file offset, and the file offset is incremented by the number of bytes read. If the file offset is at or past the end of file, no bytes are read and read returns 0. At the file offset, and the file offset is incremented by the number of bytes read. At or past the end of file, no bytes are read and read returns 0. If count is 0, read may detect the errors described below. In the absence of any error, or if read does not check for error, read with a count of 0 returns 0 and has no other effect. Oh, okay. According to POSIX, if count is greater than S size max, the result is implementation to file. Is return 0 indicates end of file. Okay, if it is equal 0, read end of file from pipe. Exit. Okay. -1 error. Exit again. This kind of make me curious. What is the exit value in here? Where does this came from? Is it from this type here? Let me check. Okay. Oh, what? Can we do this? No entry. Okay. Exit failure. Okay. Exit failure, exit success. Oh, it is on stdlib. Okay. But what is non-zero in here means? I mean, non-zero is a lot of possibility, I guess. I'm kind of curious. Let me try that. Leap. Okay. Maybe I should use that on this one. Maybe what is it called? Set failure and check using C preprocessor, I guess. Chapter S3 self pipe. Where is it? Oh, I think this one. Is it one? Okay. I mean, is it consistent one? Okay. So looks like exit failure macro in here translate to number one. Okay. That is interesting. Okay, let me try this example. In FT, negative one. Okay, not that one pipe. Okay, integer. The return value is integer. So. Okay, return code pipe FT. I assume something like that. Okay. If it is negative 0, on success 0 is return, on error negative 1 is return. Oh, the return value only 0 and negative 1. Is that it? Error return 69. Okay. What happens if we don't close the right end? If we don't close the right end. We are using right in here. Wait. So red one is 0, red one is 1. Okay. Hello. Okay. Let me try the message. Hello. Hello world. Maybe something like that. And then what is the return value? Okay. Oh, alright. S size T. Maybe we can do this instead. 1. Okay, message. And then size of message equal not that one, return value negative one return. Okay, negative 1. The error exit. Return 69. Close. Close. Something like this, maybe. Let me check. And maybe reuse. Okay. Path. Why is it? Yeah, let me check. Attempt to read up to count bytes. Let me check. Okay. Okay. What happened if we didn't close? Yeah, I'm still not really sure. Do we need this while loop? Read. Stick on. Does not check for error. Return 0 is not reflected. -1. Hello, Alpesta. Welcome. Can I start to learn this? Well, you can take a look at the description. There is some resources there, or you can take a look at the book web page. So you can check this out. There is what is it called? Some of the chapter, there is chapter of the book here, which you can take a look. But currently I'm in the chapter 5 on section homework code here, trying out to understand about pipe system call. Okay, read. Now that make me curious. Science University, okay. STT read. S0 path. Let me check. Okay. Count 1. I assume the result is its character here from Hello World. I assume. I mean, I'm not sure what will happen there. Maybe we can use switch. Read NO file from pipe. Oh, is that why we need this loop or iteration? So we read the character one by one. Well, let me try my case. Case -1. The error wipe. The error right? On what? Didn't we already check in this condition for right system call error? Interesting. On error, -1 is returned. Okay, let's just use read error instead, and maybe we can just return here. Okay, 0. read end of file. Is that the case? Yeah, let's do this instead. Make the message shorter so that we can check faster, I guess. Read end of the file. Printf read end of the file. Break default. Printf read characters. Okay. Break here. Let me try. Right, it's wait, instead of break, right? Maybe we should just maybe we should just use return 0 in here. Okay, interesting. That is not what I expect. Read end. Okay, right. I forgot. This should be inside here. That is why we only read H, right? The first character from hello. Okay, read character. I assume this is what is it called? Null terminator from the string literal. Read end of file. We can check, I guess, if of equal null terminator here. Print f null terminator. Else with character. Okay, maybe something like this. Read null terminator and then the character hello and off the file. Okay, interesting. But yeah, I'm kind of curious. Can we like check the, what is it called? Check the number of file descriptor, you know? let me try printed. S0. Oh, sorry. Again, I initialize this with -1, right? So if we put that into pipe system call, what happened? Okay, the value change, become 3. Let's try this 1, 3 and 4. Okay. Interesting. So if we remove the initial value here, it should be fine, right? Right. Okay. Guess that is why if the, what is it called? If the file descriptor is not -1, we close this file descriptor. The cleanup mechanism, I guess. And that make me wonder. Do we need to close? Do we need also to close the, what is it? The 0, the file descriptor read, the read n. Let's try this. Okay, get file descriptor. Alright, so we cannot close the read n before we read that. Okay. Yeah, what happens if we don't close the read n? And yeah, do we need to close that immediately? Let me try that. Oh, okay. Right. So the difference is when we try to read. Okay. If we didn't close the file descriptor, we will keep waiting, I guess. Interesting. Now what happens if we close that after we read an off file? Oh, okay. No, we haven't reached an off file yet. If we didn't close the file descriptor 1 or the right end of the file descriptor. Interesting. If we close this in here, Right, okay. Let me just put this here. Okay, and also S2. Okay. Alright, so if we didn't close the red end of the pipe, what is it called? We are not reaching the end of the file yet. So we need to close that. Okay, interesting. But yeah, maybe we also need to close the read end, read end of the pipe. But yeah, let me check. Should we close read end of pipe? I mean, if we return immediately, is the pipe gonna get close? The read end file gonna get close? Okay. Instead of one, 0 and 3. Wait, why is it 3? Isn't std_error 2? The file descriptor 2, not 3. Maybe that is a typo. But yeah, maybe we can use that instead of 0 and 1. Please duplicate the file descriptor for read and which correspond to std_out. Let me check. Wait. std in and out. Okay. std in file number, and this one out. Okay. std out. Wait a minute. Yeah, it is std out. But that sounds weird. Okay. Let's try this. Oh my stomach. I need to get breakfast after this. Okay. Anyway, in case anyone new, CPP in here is not C++ but the C preprocessor. I usually use this to check the macro expansion. I'm checking if the macro expand correctly or not. Where is it? Yeah, something like this. You know, in this one, if this one, and then this is the macro, right? So there is that kind of make me curious though. Is the macro cannot expand in here too? I don't think so, but yeah, it is not expand. What if I do this instead? What happened there? Okay, I don't think that is correct. Right? Yeah, that is invalid. But if we use macro, I think we can kind of convert the integer to string. You know, like concat that. Stt in file now. Data self portrait, okay. Alright. Open file descriptor. The read end of the pipe is also being held open. It's not the case that we necessarily have to close the original pipe file descriptor of the pipe. However, it is usually good practice to close file descriptor that we don't need. And that's why this program does. Multiple file descriptor can refer to the same pipe or file or author entity, and the pipe or file or whatever itself is not closed until all file descriptors that refer to it are closed. The same pipe. It's worth noting that the read end of the pipe will only see an end of file condition. Have read return 0. Read end of the pipe will only see end of file condition if the write end of the pipe is closed, meaning that all open file descriptor which refer to it are closed. Okay. You can access that. cause outside. Pipe are used for interlocking. Let me copy this in the chat in case anyone wants to take a look. Lepet file descriptor. Does not automatically terminate chat process access to the pipe. Because it's right end of a pipe, active end of file signal. For instance, okay. We are using fork, okay. Let me copy this in the reference here. Directly affect chat process execution. Continuing with other tasks. Okay, Maybe we will take a look at this on the next session. I mean, this is what we are trying to do, right? We are trying to ensure chat process always print first without calling wait or wait PIT in the parent process. So this might be related. Okay. And this one is pipe. There is also pull example. Okay, well, let's take a look at this on the next session. So that's it for now. Thank you for watching and see you next time. Bye bye.